Hi, Miss Mary here. Let's go ahead and let's do lesson 11. Go ahead and turn to page 123. We're going to go ahead and read the I can statement and give myself a sentence and a number so I can decide whether a point is on a line by finding quotients of horizontal and vertical distances. So go ahead and give yourself a sentence and then also give yourself a numbers 1 through 4. 1, I don't know what you're talking about. 2, I kind of get it. 3, I got it. And then 4, I can teach it to my friend. Go ahead and give your sentence and a number. Go ahead and turn to page 93, and we're going to start our warm-up kind of thing. And so we have this picture here. It says, for each of the following, and find each of the following and explain your reasoning. So 1, the length of segment BE, and then 2, the coordinate of E. So go ahead and pause right now, try that, and then we're going to go ahead and go through it together. All right, now since you've gone ahead and tried it yourself, let's go ahead and do this together. Let's figure out how to go ahead and do this. And there's a couple of ways we can actually do it, but what I'm going to do is I'm going to look at, we have 2 triangles on here, and they are similar triangles. So we have this bigger triangle, and we have the smaller triangle. Right? Because we have it where the angles are, this angle is the same, and then we both have 90-degree angle, okay? And then I'll make the last one angle. So all the angles are the same. We can go ahead and say that they are similar. So what we're going to do on the bigger triangle, we are going to find this vertical distance, okay? And if we look at it, we are looking at, if we look at the point, so C is 4, 2, and then D is 4, 7. Well, the 4's are the same in the X value, but the Y's are different. So how would I find this distance up here? Well, I can do 7 minus 2. So let's go ahead and write that down. We have 7 minus 2, and 7 minus 2 is 5. Okay? And so we're going to kind of leave that there for a second. We're going to do some other stuff too. And then what I want to do on the big blue triangle is I want to find the distance this way. So notice we start at A, and then we go to C. So A is 0, 2. C is 4, 2. So notice how the Y numbers are the same, but the X's are not. And so how do I find the distance between A and C? Well, what we're going to do is we are going to do 4 minus 0, because we have it as a 4 here, minus 0. So 4 minus 0 is 4. So now we have we have 2 sides of the blue triangle. Let's look at the red triangle. We're asked to find this distance here from B to E. That we don't know. We are trying to find that. But let's go ahead and let's find the bottom part. So let's find here. So we went from A to B. So notice how the y-axis are the same. So we're going to kind of ignore that. And then we go from B to A. So if we do that, we have 2 minus 0, and 2 minus 0 is 2. So I'm going to redraw this so we can kind of look at this a little bit better. So this is E, and this is B, and A. B to E we don't know. A to B is 2. And then we have the bigger blue triangle. We have A, D, and C. D to C is 5. A to C is 4. So in 7th grade, we've actually seen this before. We've actually been doing this. Let's go ahead and let's set up a proportional relationship equation. So fractions, right? And so let's go ahead and set those up. There's many different ways of doing it. I like to kind of do it this way. So I like to start with just the smaller triangle. So I'm going to do X, because we don't know it, over 2. So I have it as X over 2 equals, and I'm going to follow that same pattern, 5 over 4. And as we kind of learned before in 7th grade, we can cross multiply and divide. So 2 times 5 is 10. 4 times x is 4x. Let's go ahead and divide by 4 on both sides. So we have it as 10 divided by 4, and then that x is 2.5. And so that actually went up here on the red triangle, right? So how far is BE? Well, that's going to be 2.5. Okay? And then they ask us what are the coordinates of E. So let's go ahead and let's kind of look at that. We have it as, so how far over does it go? So if we look at it, the x value is at 2. So we have it as 2. All right, let's go ahead and turn to page 95, and we're going to do the section what we mean by an equation of a line. And let's go ahead and let's actually go through this together, because it can kind of be a little confusing. So first of all, number 1, what are the coordinates of B and D? So B is here. Remember that our coordinates are always x, comma, y. So our x is 4. And then how far did we go up? That is 3. And remember that's B. Now let's go ahead and let's find D. D is this point here. So D is 8, comma, 6. Okay. So now let's look at number 2. Is point 20, comma, 15 on line J. So a couple of lessons before, we talked about how we can kind of put things into a slope where it was the vertical over the horizontal. And let's go ahead and do that same thing. So remember, the vertical is the y information, and the horizontal is the x information. So we're going to go ahead and we're going to put the B point in the vertical over horizontal. So B was vertical, so vertical is 3 over 4. And cannot be reduced down any further. No, that's the smallest. Let's look at D. D, we have vertical is 6 over 8. And then can this fraction be reduced down? We can take a 2 out of both of them, and we can simplify it down and make it 3 over 4. So right now we can actually see, so B and D are both on this line, and we can actually look at it and see how this vertical over horizontal is 3 over 4. Vertical over horizontal reduces down to 3 over 4. Let's go ahead and do the same thing with the point that we're given, which is 20, comma, 15. So the vertical is the 15, horizontal is the 20, and then can we reduce this down? Let's think about it for a second. Oh yeah, I can. I can go ahead and take a 5 out of both of those. If I do, it reduces down to 3 over 4. So does this point, does it have the same kind of vertical over horizontal or the slope? Are all of these the same? Yes. So is 20, comma, 15 on this line? Yes, it is. So why don't you go ahead and try number 3. So pause right now. See if 100, comma, 75 is on the line. All right, now since you figured that out, let's go ahead and do it together. So we are going to go ahead and do it together. So we have vertical. The vertical is 75. Horizontal is 100. And so can we simplify this down? So we can, honestly, if you actually put it in your calculator and then kind of simplify it, keep on simplifying it, see until you can do do it as small as possible. Does the 75 over 100 it reduces down to 3 over 4. So is this point on the line? We'll see how we have 3 over 4, 3 over 4, 3 over 4. That answer is yes. This is on the line. Now, since you've done number 3, go ahead and do number 4. See if number 4 is also on the line. All right, now since you've tried it, let's try it together. Let's do 68 over 90. And can we reduce 68 over 90? Can we reduce that down? Yes, we can. So simplify as much as possible. Calculators are awesome at this point. If I reduce this down, this reduces down to 34 over 45. Now let's go ahead and let's check that. Is 34 over 45 the same as 3 over 4? Well, no, it's not. So is this point 90, 68 on the line? The answer is no. So let's go ahead and let's look at number 5. Suppose you know the x and y coordinate of a point. Write a rule that will allow you to test whether the point is on line J. And so what we've been doing, so what they're actually kind of saying, they're saying, okay, my point is, instead of being numbers, it's going to be x, comma, y. And so what have we been doing? Well, we've been putting that point into a slope, or the vertical over the horizontal. So vertical is y, horizontal is x, and we've been comparing it to 3 over 4. And so this is our rule as far as for this question, as if we can find out if a point is on the line. So notice how we have x and y. This line also goes through the origin and then kind of comes up. And so we can actually just write it as y over x equals 3 over 4. So for today, we're going to be working again with a picture, kind of like as we can kind of see. The line goes through 0, 0, and then we're dealing with the x and then y. So remember, we have x, y, and so we're going to be working with this. So kind of keep this in mind, and then we're going to go ahead and do our next activity. All right, let's go ahead and turn to page 96. We are writing relationships from slope triangles. And so there are 2 diagrams. We are going to be doing both of the diagrams, but we're going to focus on the first one first and then the second one second. But what I did is I took the picture and the directions and I put them together. And so our directions are, here's a diagram. Complete each diagram so that all vertical and horizontal segments have expressions for their lengths. And then use what we know about similar triangles to find an equation for the quotient of the vertical and horizontal side lengths of triangle DFE in each diagram. And so we're just going to be focusing on the first diagram itself. So let's look at the 2 triangles. So these 2 triangles, they are similar. So notice how they are on the same line. And we did this a couple of lessons ago where both triangles are on the same line. This one, our vertical is 3. It's already been labeled for us. Our horizontal is 4. It's also labeled for us. Now let's go ahead and let's look at triangle DEF. So we need to label our vertical and our horizontal. Notice how this point is 0, 1. So it starts, as far as the kind of side to side stuff, starts at 0 and then it goes up to F. Well, F is not really on here, and we can kind of say, well, I think it's like 2.1, but we don't know what it is for sure right now. So but we do know that that side is the X value, or it's the horizontal. And remember, when we were talking about horizontals, we called those X's. Now let's look at the other part. So do we know between E and F? Well, we could assume what it is, but we don't know what it is right now because remember, mathematicians don't assume anything. And it is my vertical, and remember, we always label the vertical as the Y stuff. But also notice, and this is kind of what we did in the activity before, so this is a Y going all the way up, but we also have to understand that we also have this. So we're looking for E to F, right? And E to F is not just Y. We're going to do Y, and then we're going to take off kind of this bottom part step, which is 1. So really, E to F is really what we're looking for. E to F is going to be Y minus 1. Okay? So again, it's going from the x-axis all the way up, Y, and then we're going to take off this bottom part here because the triangle actually starts here. We're going to take off that one step. So we have it as Y minus 1 will make the E to F. Now, since we have our triangles, all of them are labeled, we're going to go ahead and we're going to make equations again, just like we did in our other activity, and we're using the slope triangle. And so what we're going to do is, remember, our slope is our horizontal over our, is our vertical over horizontal. So our vertical is Y minus 1. Horizontal is X. And we're going to do the same thing with the other triangle, and we're going to make this one blue. Okay. And so on the blue triangle, we have it as our vertical, which is 3, over horizontal, which is 4. So we've now made an equation, because remember, equations have equal signs in them, and we are using quotient. So remember, quotient is a fraction of the vertical and horizontal sides. So our vertical and horizontal of the smaller triangle, vertical, horizontal of our bigger triangle. So we've now made an equation for diagram 1. All right, so let's look at diagram 2. This is on page 97, is the picture. And again, we're going to complete each diagram so that all vertical and horizontal segments have expressions for their lengths. And then we're going to make an equation with it, just like we just did on the other diagram. And again, we're going to go ahead and we're going to do it together. So because it's a little confusing. And again, if you need to go through this video, again, until you understand it, please do. So let's look at, so these two triangles, they are similar because they're on the same line and they have 90 degrees, okay? So they're similar triangles. On this, I'm going to go ahead and make them different colors. So this one's blue, okay? So we have this blue triangle, right? On our blue triangle, our vertical is 3, horizontal is 4, okay? So those two sides they're labeled. Now we need to go and label the E to F and D to F. And so let's do E to F first, because that's kind of what we've done in the last two activities. So remember that we don't know where E is. We could assume, but mathematicians don't assume things. But we do know going from all the way from the x-axis all the way up is Y, because that's the vertical stuff, right? Okay, so we do have our Y, but then we need to go ahead and find between E and F. So to find E, remember it goes from the x-axis all the way up, and so that's Y, because we don't even know what it is, but we can go from the x-axis up to F. And how many steps is F? Well, okay, we can pull it from this point, but we can also count it. 1, 2, 3, 4. So we're going to have it as, we can make that side as Y minus 4. So again, it goes from, the E is from the x-axis all the way up. We don't know where it is. It's Y. But then we can go and take off the F part from the x-axis, which is 4. Let's go ahead and label the horizontal. So again, F, we really don't know where it is. Okay, we don't know where it sits, but we do know it comes from, so from the y-axis all the way out, and remember the side-to-side stuff is X, and then remember that we need to go ahead and we need to take off the D, because remember, if we go from the x-axis all the way out to F, and then we go from the y-axis all the way out to F, and then we take off the y-axis all the way out to D, we would get the point from D to F. So y-axis to D, well, that's 2 steps. So we're going to do x minus 2. And again, if you're confused on this, go back through this again so you kind of understand the pattern as far as what we're doing. So this is number 1. We've labeled both triangles. Now let's go ahead and let's make it an equation. So remember, we have our, and we're doing it over and over again, we're doing our vertical over horizontal, and we're looking at the 2 triangles. So our vertical is y minus 4, horizontal is x minus 2. That's our smaller triangle, and then let's do the same thing with the blue one. We have 3 and then 4. So it's vertical distance of the triangle, horizontal distance of the triangle. So this is our equation for this diagram. We have y minus 4 over x minus 2 equals 3 over 4. So to kind of help us again as far as what we've been doing, we've been actually labeling triangles, okay? And so remember that we have it, if we're doing the vertical, so we go y minus 1, and that makes this distance here. And then horizontal, we have x minus 1, which makes this distance here too. And so this is what we're kind of going today is we're understanding and making equations with these slope triangles because they're on the same line. And then tomorrow we're actually going to be using them a little bit further. So let's go ahead and let's turn back to page 123. Let's read our I can statement. I can decide whether a point is on a line by finding quotients of horizontal and vertical distances. Go ahead and write yourself a sentence. And then give yourself a number. 1, I'm still confused. 2, I kind of got it. 3, I did get it. And then 4, I can teach it to my friend. So do your sentence and your number. So this is our lesson for today. Make sure that you go ahead and do the practice problems. I've also made extra practice as far as labeling the triangles and making the triangle equations. Make sure you do both of those assignments for today. It's going to help you because next week we actually have a quiz and then also a test. And so it's coming up really far. So I hope you have a good day. Thanks. Bye.